everyone. Today we are going to work on the Leetcode problem clone graph. So in this problem, you'll be given a node and you need to return a deep clone of the entire graph. So it's a case where each node has a property called value and another property called neighbors, which is the list of all the connected nodes to it. So this problem is pretty straightforward, but there's one caveat that people miss, is that it is not a connected graph but an undirected graph. So what I mean by that is from 1, if you are looking at the neighbors, it'll have 2 and 4. And from 2 again, when you're trying to see the neighbors, is going to be 1 and 3. So a lot of people, they make the mistake that when they're trying to solve the problem, they try to do it by recursion. So they say, let's create a deep clone of this node. And they recursively call each of the neighbors to create them. So when that happens, it's a case where say 1 has a neighbor 2, 2 has a neighbor 1. So you keep recursively calling it again and again. It ends in an infinite loop. So that's the only caveat while solving this problem. Other than that, it's pretty straightforward. It's basically you need to create use the new keyword to create a new object. That way you're assigning a new memory for each of the objects. So yeah, I think just to keep track of whether the node has already been created or not, we are going to use a hash map. Alternative is to use an array, but a hash map is easier to work with. So yeah, let me just add it. And we just say a new method called return. And we say a node. And we return the pass in the hash map. So this is a method which I already created. So it takes in a node and a hash map as input. First thing is we do a null check. Say return node. Else we just now create a new copy of the input node. So we say node copy. And we pass in the input value. So here they have given us the input of how to create a node. One of them is you can pass an integer as input. So initialize a node with that value. And we'll also initialize an array list of neighbors. So first thing we're going to do is add it to the hash map. So hm.put. And obviously the copy. And we just say return copy. So this should be the final output. Now we also need to generate each of its neighbors. So we are going to do that recursively. So what we're going to say is for in dot neighbors. So if the hash map already contains the node, we don't need to create it. We just pass the value from the hash map. So hm dot contains key. Just say copy dot neighbors. So here essentially what we're doing is we check if the hash map is containing the value. Since we are saving the integer as the key and the node as the value, we're able to just return the value hm. Yeah. Else we're now going to create the node recursively. So we say that node clone we pass this value as input and the hash map. So n and hm. And similar to what we did here, we just say copy. And here we add the clone which was recently created. So yeah, I think just to recap, we use a hash map to keep track of whether the node has been created or not. And then recursively we keep generating nodes based on whether or not they have been created, and we add it to the neighbors. And at the end we just return the node which we have generated. So all these nodes were created using the new keyword. So that way it's a deep clone rather than a shallow copy. So let's try running the solution. Oh, I think I must have made a mistake. Where did I go wrong? Oh, I think think this is wrong. So I should say n.val. So yeah, this is the value we are going over. Same thing with this. We should say if it contains n.val. So yeah, I think it's wanting to use better variable names, I think. Everything else looks good. Let me try again. So 3 use cases have passed. Let's try submitting it. So 61. I guess we could have improved the memory a little bit or make it faster by using an array. So that's an alternative way. Since they've already mentioned in the description that the value will be something from 0 to 100, that's an alternative could have been to use an array data structure to store generated nodes. So that's an option. But other than that, I think the solution should work in most use cases. So yeah, leave comments. Let me know if there's a better solution for this.